Hello everyone, so this is the third live stream in which I'll be programming the RPG engine that I'm building currently. Thanks for joining me, if you're either on Twitch or on YouTube. Last stream we were able to get this thing working where we've changed the materials and we messed around with changing the block types as well. And the most important thing that we'll be working on today, and it will actually be quite important later on as well, is getting these blocks to change dynamically so that they smooth out some of the rougher edges on the edge of blocks. So what I mean by that is, you know, this bit for here, for example, might turn into a ramp, or same with this block, or this top one might turn into a corner wedge like what we've got in the basic block section here. So the goal is to take these existing shapes and change them in such a way that, or rather change the shapes that we make out of these blocks in such a way that it's a bit smoothed out and that it's kind of like an optional thing. It's not something that we force on the editor later down the road, but it's something that can be chosen if, say, you're editing terrain, for example, and you want your terrain to be a bit less cubey. You know, this isn't Minecraft after all, this is an RPG editor, so the whole point is that while it's not supposed to look realistic, it is at least supposed to offer some flexibility in terms of terrain types. So today is mainly just about thinking about that problem and thinking about how we're going to tackle it. It's because it is going to be quite challenging. There are some things that have yet to be solved from yesterday, like how to deal with blocks that are upside down, for example. That'll be a bit of a challenge, but it will be something that I'll come to in the second half, hopefully, of this live stream, if we make some decent progress, or something that we get to another time. Right now, we just want to kind of get the basics in and working, and hope that it ends up looking nice, essentially. And if it doesn't, then we can always make some tweaks later on, but for now we're just getting the basics in. So where to begin with this problem? Essentially we're looking at this from the user point of view, or at least the user, in the sense that I will be using these functions later down the road, not necessarily from a UI point of view, but we obviously need some kind of variable, I would say, for tracking this. So we've already got a few here which I haven't actually made use of yet, but will probably be important nonetheless. So I'll add in a bool, since it is just a true or false setting, called, I don't know, let's call it voxel smoothing, I suppose. That makes the most sense. By default we want it to be false because it's not something that should always be on necessarily. Like, we don't know if the user will want smoothing all of the time. And to make a start on this, we're probably going to need some kind of wrapper function. And what I mean by that is, we've obviously got our basic shapes already, but it's not necessarily clear to me that we want to change all of these directly. Some of them maybe, some of them maybe not. So if we have a look at what we've already got, just to kind of assess what we should do with this, we've got a single voxel. So a use case, like basically how this will work is, we'll look at not just the block itself and what smoothing it should do for itself, but also what's going on around it. Like, do we need to do anything in the immediate vicinity? Because ultimately it's changing not just itself, but also its connected blocks as well. So I think that kind of thing will be quite important. So it's pretty much kind of the same methodology for the rest of them. The columns, for example, again, we're not just changing the column itself, but the outer layer as well, everything around that. Same with planes, it's the thing that we're actually affecting, but also everything around those. Circles are the same, ellipses are the same. So we could take two different approaches. We could wrap all of these in a function that applies all of that smoothing automatically, or we could embed it in these functions. And I think for now, the best thing to do would be to embed it in these functions, just so that for the simpler ones, I'm not having to write the same stuff over and over again, and I don't have to track every time what has changed and what hasn't. So if we... Because one dilemma like I have right now is if I was to take a generic approach, like let's say I took the volume that the brush took place in, and that was a cube or a square or whatever the case may be, then I'd have the issue of, well, let's say we made a circle and then it changed the whole cube region that circle exists in. Then I'd be smoothing out blocks that aren't necessarily directly affected by that brush, and that would be a problem. So we need to come up with a custom solution for each function, just in case the shape behavior is a bit different to just your standard squares. So I think, yeah, that's probably the most sensible solution, is going through each one of these and coming up with a way to perform smoothing on that shape type. So it's obvious to me that, like, say, changing a single voxel and the columns and the column ranges, they'll all make use of some kind of square or cube. So we can probably make just one generic function for kind of handling those. I'll just make this a bit nicer, just split these up a little bit because they're separate from the brush types. So we'll move those down, and then we'll have a function called call it like smooth cube, I guess. Sensible name. Maybe not the most descriptive, but it'll do. So just like with the rest of them, or rather with the cube range, we'll want to set an x min, an x max, y min, y max, and so on. We don't need a material. Oh no, sorry, we do need a material this time because. Oh no, thinking about it, I don't think we will. So what we'll do is just take these, because we don't need any of these additional parameters. They kind of are calculated within the function itself. So we'll just take these ranges for now, since these will define the changed volume. And now we need to work out how to go about this. So what's probably sensible to do is, first of all, set up some kind of for loop. And actually I shouldn't be doing my function body inside of the header file, should be doing it in a new place. So create it within the implementation file. We can scroll down on the left down to where that's just been made. So the most sensible thing to do first of all is to just create the kind of standard for loop that you would get, just to iterate over each of the spaces, and with that we can edit each individual voxel. So we'll go and grab the for loop that we have from the change voxel cube range, so we need to just find that quickly. Here we go. We'll grab this. Place that into there. And this is where we need to start thinking about what kind of logic we want for this problem. So what we can do is we can, like the reason I said that we didn't need any of those additional parameters, like the shape and the material and that kind of thing, and the rotation, is because they're already part of the data array that stores that data here for Voxel. So we don't need to know kind of outside of the function what each of these already are, because we can reference them directly. So obviously we kind of need to spawn something new. So we need to, I mean, just like any of the other functions that we've done, we need to change Voxel. But in this case, we need to decide both if that's going to happen, like under what conditions is this going to happen, like does it need to be changed at all, say if it's in between other blocks, like if it's just surrounded by them. Obviously in that case then no, because it's not visible and it wouldn't make structural sense. So we need to decide when that happens, and we also need to decide what properties go into here. This is a simple one because we can just kind of pull, I believe we can just pull out of Voxel data for that. So we can do Voxel data X, Y, Z, and then we can say we want sorry, it's not X, Y, Z because of the way we structured the array. We want the material here, and then we do the X, Y, Z here. So essentially we already have our material type, we know what it is, so we can just pass that straight back into this this definition, parameter for change voxel. Same with the shape. Like we already know essentially what these things should be. Sorry, let me start again. So we already know what material should be. We need to determine what the shape and rotation should also be. So I guess to determine whether or not this function should take place, we should start off with some kind of bool that we can use as checking. So we'll just call that should change, and we'll just make it local because it doesn't really matter anywhere else. We'll give it false as a default and then determine if it should be true or not. So if we go back into our game, let's start thinking about what kind of edge cases probably might require a change. I think first of all the obvious thing is it contacting air, or rather is it not completely surrounded? That's something that's fairly obvious. But also we need to take into account the relative depth of each corner. So what I mean by that is the nearest block or corner lower or higher than the current position? So if we take this edge as an example, we can look at the adjacent blocks and we can say, okay, this corner here is one lower, this one's one lower, this one's one lower, and this one is the same height. So to me, I would take that to mean that this edge should be flat, this edge should probably be flat, and this corner should be raised. So I would say this block, like to me that kind of makes sense, but then we also run into the issue of, well, if we're doing it for Like if we're lowering and raising this block plate based on its adjacent things, do we then have to do the same for this? And if the answer to that is yes, then we need to be careful with how we do that. Because obviously this can't then be a ramp as well, just because this one is elevated, because then we'd end up with a wedge shape where there shouldn't be. So I think the way that this should be thought about is what's lower and what's higher. Like so what I mean is, like, this top face, we determine what's lower than the default height of this top face, and then come up with what shape we need and what rotation we need. Same for the underside as well, actually. So the underside will kind of look at the adjacent blocks and we'll say what's lower and what's higher. And then if it is lower or higher, we'll change the underside shape of that. We also get into an interesting edge case where, let's say we think that the top and the bottom should change. Like, what happens in that case? Because then what we could do is end up with a situation where we've got two kind of wedge shapes that need to be made, but in different directions. I think that might be an issue too. A lot of this stream, like, I'll apologise now, it will just kind of be me working through this problem and like figuring it out, because it is quite complicated to think about, and like there's lots of edge cases that we might run into, lots of things that need to be thought about from a designer point of view that might make sense to do but might not necessarily be easy to determine, like what shape should be used. Okay, what I can do, I guess, to think about this in a slightly different way, like a more visual way, is I'll open up Paint and we can maybe start doing some different scenarios kind of to define the problem and then work out how to solve it. So we've obviously got how many sides? We've got, I think, 6 sides per cube. So you'll have to excuse my poor drawing. So if it's kind of free floating, we don't want to change that at all. We kind of want to leave it in its default state. If it's got something just underneath it, again, we leave it in its default state. Same with on top, like if it's one block on one side, no changes. If we've got a block here and a block here, again, like there probably shouldn't be any changes made to that. I think it's when we start getting into, if there is a block on the diagonal, like that's when it should change. Like if there's a block in a diagonal space, that's when we start making adjustments. So if there's a block, say, in this like lower corner from it here, that's when this edge here would need to be lowered. Same for if we had something, same if we had something here, this edge should be lowered as well. So looking at the shapes that we've got as a base already, like it doesn't necessarily fully make sense to just stick with these. Like from an art point of view, I'm probably going to have to request like some different models, or at least that these are split up a little bit. There's also another case where, let's say we've got two diagonals, we've got a block in this top corner and a block in this bottom corner here. We don't want to lower this edge because then this wouldn't be connected. We also don't want to do the same here. So there needs to be like some kind of imbalance. It needs to be above or below, not both. So if we've got something in any one of those positions, we need to make sure that there's also not something in the opposite plane on that side. Then we can't make the adjustment. And we also need to think about this in terms of like lowering corners. So let's say if we had a block in this area here, but in anywhere in there, probably both of these sides would need to be lowered down to meet that, so long as there isn't something up here as well on this top edge. This is a really difficult problem to define. Probably take a lot of thinking about, and probably trial and error for the most part, to be honest. So since we're thinking about it in terms of corners, I guess it would make sense to work out kind of what the average sum of the adjacent corners is. Like, I guess that makes sense. So we can say that, say if there's 3 blocks down here, right? We'll probably want to, like, say we have some cubes all down here. We'll almost certainly want to lower this corner down to that point. So in that case, it would be -1 plus -1 plus -1. If one of these was slightly lower, let's say it was down here, then it would be -1, -2, -1, which would be -4, and therefore we know that this corner needs to be lowered because it's lower than 0. If, just for clarity's sake, I'll draw a new cube, but if we had something adjacent, well then we can say, well actually we have, well let's do the maths on that again using that same system because it seems to kind of work. So we'll take all adjacent spaces, so we have, let's say, a cube down here as well. I'm terrible at drawing, you'll have to forgive me. So in this case, we'd want to say, well, because there's -1, 0, and let's pretend there's a cube back here as well. And -1, that'd obviously produce a net of -1, if we normalise it, then it would produce a net of -1 for this corner, and this corner should definitely be lowered. Same for this one, since there's -1 as an average and we have no other blocks to compare to, we'd say that that's -1, and we'd lower that down. Another thing that we also need to factor in is we only really want to be doing that if there's something connected either above or below. Like, you only want to be doing these relative adjustments if, say, there's a block like actually touching the thing that you're trying to change. So if we wanted to do this corner here, we want to lower this corner and only this corner when we're cycling through each position, and we don't want to say, well, let's take another case. We don't want to edit the corner if they're not connected, because then there's no point in smoothing them. They're two separate entities at that point. And again, we can't be editing those corners if there's conflict. So we need to be checking each corner, all of the adjacent blocks to that corner, like everything that touches it, and we need to get a kind of an average. I'd say that's the best way to approach this. It seems to make the most sense, it seems to work, and that's how we determine what position to lower or raise. The final dilemma that kind of pops up in my head is if, say we determine that we need to lower or raise, I don't know, let's say there's a block up here, and the smoothing determines that we need to lower this corner. Like, would that be acceptable if, say, both of them, like if we needed to lower or raise both? So let's say in this case we had two cubes like that. We obviously can't lower or raise each corner. So it's kind of like a balancing thing, I guess. Like, not only do you have to factor it in terms of just an individual corner, but you also need to factor it in relative to itself. So this corner and this corner have to be considered at the same time, just in case we do, say, want to edit both. But we can't, because that would mean essentially removing the block entirely. It's a tough one. So yeah, we need to first of all do this individual offset. So we work out for each corner what we want. So in this case it would be, let's say we're dealing with the 4 top edges. And let's say there were blocks lower than it all around. So like all around this section. We want to lower every single corner. That's what the relative to the point algorithm would determine. So we'd say -1, -1, -1, -1. But then obviously looking at that, we can see relative to each other, there's no actual change. So I guess we should look at this pattern and see if there's any kind of variation. So there would be variation, for example, if it was just one corner that was -1. So if it was, say, I don't know, let's say it was -1, 0, 0, 0, then we'd know that we could edit just this one corner and we could use one of these blocks, and in that case it would be this one. So I guess we're looking at this from a bit pattern point of view. But of course we also need to take into account the fact that there are multiple faces that we need to consider. There are two faces that we need to consider. There's a top and a bottom. So if we were to say calculate two sets of bit patterns, we've got top face and bottom face. We first get the result for this corner, and the only thing that it should be is either a lower or zero, so -1 or 0 for the top face. So let's do a random one. Let's say we've got -1, -1, 0, 0. So that would be a ramp in this case. And then the bottom face says, okay, so we want it to be, and because the bottom face is like a positive thing, it's going up instead. Let's say we've got +1, +1, +1, and 0. Is there kind of a solution to that, like a middle ground? Like maybe I don't know, maybe we end up with, let's say, like, because these are kind of opposites, we'll neutralize that. We get 0, 0, 1, 0. So from this pattern we've come up with this block, which would be, I think, this one but upside down. No, in fact it would probably be this one. Yeah, it'd be this one upside down. Like, I don't know if that would work. It might do. It might look okay, but it might lead to some interesting results. Like, what happens if, say, we've got oh, I don't know. Let's say we've got -1, -1, 0, -1, but then we've also got +1, 0, and then a +1 here. And another 0. Then in this case we'd end up with a negative, a positive, a negative, and a 0. So like, there isn't really a clear solution. Like, do we then, like, I guess we'd edit the top and bottom face independently? So I would need to have these blocks broken up into separate parts so that we could have the top and the bottom face doing different things. Which I guess makes sense. Like, in this case we'd have, like, if we broke these shapes down into its component parts, we could, for example, I guess have this top face here duplicated but upside down, and then have it doing the opposite thing. So like, it'd connect along this central divide here and have the inverse shape. Like, I think that would kind of work, but I'm not entirely sure. So I guess we'll go through step by step, like what's already been worked out through this, like, kind of rambling on with this drawing, and we'll see if we can kind of get closer to a solution. I guess we've just got to do this incrementally and see what happens. So starting off with the function, we need to determine what shape we need. So I guess we can break this down into further functions just to make it a little bit easier. We'll make one called we'll call it corner value for now. I'm sure I'll come up with something more descriptive later. And we want it to take in, well, the XYZ position. And then also what corner it is that we're trying to change. So if we index the corners from, I guess, well, there's 8 corners in this case. So if we give it an int called corner ID, and then within this definition we the switch using corner ID, then we can determine what kind of behavior we want for each corner that we're checking. Like, we determine what relative space it is that we're checking. So if we say case 0 is kind of like your x and y 0, then we'd want to be checking kind of everything negative to it. So we kind of need to look at, like, say, the negative x block, negative y block, and then the negative xy block as well. But we need to kind of store the results of those and find a way to kind of tally it up. Yeah, I apologise while I'm just trying to work this out. So I make a new variable called offset tally. And I think eventually actually this will be the thing that's returned. And as much as I want to avoid it, I think the best way to do it is make an if statement for each position and say if this location is like, say, negative or positive such and such, then like add or take away from this offset tally. Trying to think of a more elegant solution to this problem, but I'm not entirely sure if there is. So case 0 is our x0 and y0 on the top face. So we need to determine if there's anything opposite that would change it. So if we go x, to bring up this again, Let me create a new canvas. Don't want to save it. So we're currently dealing with this corner down here, right? We want to see if any of these spaces below it would cause this to change. So the thing that we're checking against for this block here is if, I guess it would be negative y, negative z, and yeah, if negative y and negative z is occupied in this position, then we decrement the variable. Same for these, but only if there's not already something directly adjacent to it. This is a really tough one to solve. Because what happens if, say, there's a block here, but there isn't here? And in that case, I guess we'd still want to decrement it a little bit, right? Right, well, let's just go with the tally idea and see how far we get with it. So if what would we reference here? Probably visible meshes. Yeah, if there's a visible mesh, let me just double check if I did that before. So now I've got some code that checked if there was a block in that place. Yeah, so it's literally just this. If there is something there. So if x minus 1, sorry, no, it's not x minus 1, if y minus 1, z minus 1 is equal to oh no, that would just check if it's occupied. So if we've got something in that position, then what would we want to do in this case? We'd want to probably just decrement this variable. And then we'd have to do the same thing for all of them. Kind of a pain, really. Let's see how other people have done it. I'm sure, surely there must be some kind of there must be some kind of existing algorithm or implementation. You'll have to bear with me while I look it up on the side and see if I can find anything even remotely related, because it does seem like it would be a very tedious process doing it like this, where I'm checking each individual face. Like, it seems like it'd take a long time. I think for now what I'm going to do, rather than concern myself with doing like the underside of the cube, because that will make it very complicated and I'll run into all of the problems that I was talking about earlier, I'm just going to look at doing the top face, because at least then I know I don't have to do any rotations or anything like that. I can just kind of deal with one set of variables, and then afterwards I'll determine how to calculate whether or not something needs doing on the bottom side, and then I can also work out how to deal with any conflicts that may arise as a result of those two systems kind of fighting against each other. So yeah, that makes it a little bit easier. So what we can do is essentially copy this. So we've got the 3 checks that we wanted to do. But in the other case, we've got x -1, y -1, z -1, and then we want just x -1 for the final one. We're checking each corner, we're saying if any of these need adjusting, we'll add it to the tally. And then we know that, well, let's instead put if, oh no, these are quaternion, so, sorry, not a quaternion, what do you call it? Ternary operator, that's what I meant, not quaternion, ternary. So if offset tally negative is less than 0, we want to return -1, and if it isn't, we'll return 0. There we go, simple. And then that stops it from kind of returning all kinds of crazy negative numbers, which we don't actually need. So now that we've got like a rough way of doing, obviously we'll need to update this for every single corner, but now that we've got a rough way of returning what the corner adjustment should be, whether or not there should be any or not, we need to work out how to store that up here. So I guess we go through. We have a for loop. That is for each corner we want to call corner value pass in the X, Y, Z, and then also I as well. That'll tell us what kind of edge it is that we're looking at. We need some kind of I guess we could store it in an array. That'd make the most sense. So we want it to be 8 large. And we essentially want to say, like, for each of these positions, so we're running through each of these blocks, and then every time we get to a block we're saying, okay, let's make a place to store all of the offsets that are relative to each other. And actually let's edit this just to deal with the top face like I was saying. So let's for now just keep it as 4 so that we're only referencing 4 different positions. Like one for each kind of top corner. We want to say that corner change is equal to what this returns. And then I guess what we do is we make some kind of case statement for working out kind of like what pattern to use. So we'll have like a bunch of cases for, like, I don't know, so if the first position is -1 or if it's 0, and like unfortunately yes, that does mean doing a lot of code. Like, there will be a lot that goes into this, I think. Like, I don't like doing a lot of hard-coded stuff. I find it very messy a lot of the time, but unfortunately with some of this stuff it's necessary. So now we've got a function for it. We can use the return value to determine the shape that's returned. We'll add to that in a moment. I'll leave that as is for now. So then we want to determine the block type. We'll pass in corner changes. Actually, just corner changes as a variable. And out of it we'll get so right now I'm just determining the flow of the program. Like, I'm not actually setting up any of the logic quite just yet. I'm just kind of saying, right, this is roughly how I want it to work, and stepping through each of the processes that will go behind that. So we're saying if the new block ID is not equal to the current one, it should be shape ID rather. Oh yeah, of course, and then we're using this rotation factor as well. So to simplify this, oh, this gets even more complicated. Right, okay, so another thing that you can do in C++ is you can pass in a reference. So what I'm going to do is change the determine block type parameters to include references to these variables. So we want let's call it shape and rotation. So now we're passing these in instead. And in fact, we'll just, to make things a bit easier, we'll in fact, no, we'll keep that in, and we'll say basically the same thing, but rather than checking the shape, we're just checking the rotation instead. and that should be an OR, because we don't only just want it to change if one of them isn't true. Or if both of them aren't true. It should change like if any of the values don't match. Okay, so let's go from the top. Let's see what kind of thing we've got now. So what we'll do is we'll be saying, and we no longer need that, I don't think. We'll say, we'll make a thing to store all of the corner changes, whether or not we need them. Then we determine that by running this through function and returning whether or not there should be an offset. Then we're getting the new shape and the new rotation, passing those in as references. I don't know if we need to declare these actually as references, possibly. No, I think that should be fine. And then we say if they're different, like if either one of them are different, then we change the voxel to the new thing, which I think makes perfect sense. I think that should be fine. So now we need to just go through and do all of the like logical stuff for it, like we were doing before. So kind of a copy of this, but obviously changing all of the positional data. So we want 1, 2, and 3. So this is for all of the different cases that we've got. And then we say we want this corner next. So we need negative y again, negative z, kind of similar to before. Then we need positive x, negative z, and then and also negative y as well. Yeah, I think that's correct. We've already got one up here which uses the same block. Then we want +1 in this case. And same for this one as well. Then for this one, we're doing kind of all positives apart from negative z, so we need x +1 y, then x, what is it? Yeah, x +1 again. This time we need y +1. And We just need x and y plus 1. I apologise for this being like tedious, by the way. I know it's a frustrating like thing to watch. We've got y plus 1, then we need x minus 1, y plus 1, y, x minus 1. Yeah, so I think that's right now. I think that checks everything. Basically just seeing if any of these things are satisfied, decrement this value, and then return either -1 or 0. Yeah, I think that function's done for now, until we revisit it later with bottom side calculations as well. Then we'll have to make some slight changes, but hopefully nothing major. So that's fine. Now this is where it gets complicated. We basically need to find out if it satisfies any of the patterns. So we'll go down to determine block type. And we of course need to reintroduce those variables that we were going to add in initially, and I'm going to see if I can just bring up my header file again quick. I don't know if you can like make a case for a pattern of variables. I don't think you can. So I'll have to use an if statement instead for each of these. So if corner offsets 0 equals 1. Basically this is just going to be like a tedious process, checking each like pattern type and then seeing if it lines up with any of the shapes that we have. So basically there's just this process repeated over and over again for the different types of shapes that we have. So if they're all -1, and we don't actually want to do anything, I think we just maintain its shape. And why is this not liking? Oh no, now it likes it, okay. then the shape that we're using would be, I think we had it as 1. I think that was the thing that we had it in the shapes function. So we can essentially do the same thing for each shape. So if I go up to where we had our set shape thing, set block model, here we go. We currently only actually have 4 different things. I think it's just the order that I've got them in the editor. So we'll work out different cases for different stuff basically. I'm not entirely sure how many different combinations there are, but I know that there's a few. And I know that we don't actually have all of the shapes for these just yet. So we'll just for now do the things that we already do have. We're double checking the editor just to see what shapes we actually do have currently. We've got -1, 0, 0, 0, -1, -1, -1, 0, which is something that we're just editing now. -1, -1, 0, 0. And that's it, I think, for the moment. There are more shapes that we need. I can't remember exactly how many, but we can just add to those over time as of when they kind of become important. And one thing that I'm going to do actually to make this whole process work is every time we check the bit pattern that we've got, well, it's not really a bit pattern, but it's kind of equivalent. We're gonna check it, so using these if statements, and then we're going to shift all of the values around, and then we're going to check it again. And then if we get a match, we're going to take the amount of runs through the for loop that it's used and take that as our rotation. I think that's probably the smartest way to do it. So int I equals 0. How many runs do we want to do? I guess we want to check 4 different rotations, don't we? So we'll run it 4 times. Yeah, we might have to reorder these values just a little bit. But then also we want to say that the function there we go. So the rotation is I times 90. Oh, actually no, it's just I, isn't it? Because yeah, I didn't. Just a rotation ID, which I've already got set up elsewhere. But then we need to also do the shifting as well. So. Actually, yeah, we'll give this a different name, so we don't want it to get confused. So thinking about it here, we just need to take the existing one, So basically we're going through each space and saying that, you know, corner offsets j equals corner offsets j plus 1, and then at the end of it we also want to say that the last space and the reason I've, by the way, done it hard-coded like this is in case we end up with a lot more data. I only have to then change a few things around. Corner offsets, I think it will be 3 equals temp shift storage. And then it'll run the whole thing again. So it'll run it through, see if it matches this pattern. Set the shape to the appropriate thing. If it does, so it'll shift through, set it to the appropriate shape if it finds anything. But in the event that it doesn't, it'll just loop around again and carry on doing that until it finds something, essentially. And then it will return the two things, and actually this shouldn't be an int anymore since we're passing them in as parameter types anyway. Get rid of that now. We also want to give these default values as well, just in case nothing's actually changed within that thing that we've just made. And then obviously the block stays the same. And then I guess we now have to line up the blocks that we've got already in terms of rotation and model and all of that kind of thing, like the IDs with the thing that we've just made. It's not going to be perfect initially. I don't think it's even going to give us the right block types currently. I don't think shape 1, for example, would look the way it does. I mean, okay, so no, this one's fine. Let's double check what shapes we've actually got. So, got one where it's just, I think this is ID 2. And that's where one of them is lowered. So if we shift this one up and then shift that one down, I think that's correct. So let's just double check again. So the third one is this one here, which is one is up. So no, so now we need to shift this one again, that down. And this one is where just two of them are. Yeah, that's fine. Now rotations wise, I'm not entirely sure what position it needs to be in, but for the second one, we're checking this corner first. So that's correct, yeah, that's -1 in that position. For this one, it's the first three, a -1. Yeah, that's correct. Oh, thanks for following that. Awesome, it's my first follow I've had in a while actually, so I appreciate it a lot. And then this one here is... Yeah, I think that's correct. I think that's the first two corners that we're checking against here and here to be -1. Nullx, yeah, if you stick around, like hopefully I'll solve all of this stuff and then we'll actually see some results on the screen, so it'd be pretty cool. I think I'm pretty close. Like this should seem like this all seems to like be okay for now. I don't know if it actually does the thing I want it to. Like I'm not calling it anywhere just yet, so I can't test it. So that's the next stage, I guess. But we're close at least. I don't know why I did that. Let's maximize that again. So now we want to call this whole thing. We've made some we've made the functions, I think, as they should be and as they should work. So now we just need to kind of embed them in one of our shape functions just to see if it actually does the job it should be. I guess the best thing to test it on is the circle, really, or the ellipsoid would be a good one to test it in. And Nullx, thanks a lot. Like, it's good to know that at least somebody enjoys it. I know it's kind of a niche to do programming on Twitch, so I hope I can make it somewhat entertaining. So if we go to... Where are we now? So if we go to our voxel ellipsoid, right? So we've got this function already. We now need to apply like a general smoothing to it. So when doing this like properly for the circle, like this isn't fully how... This isn't the actual function that will be used. Like, we want to adapt it so that it's not setting a block area, so it's not just smoothing a cube. We want it to smooth an actual sphere, but this is the easiest thing to test it on because it has the most complex geometry, basically. I'm trying to make a roguelike in C++ ATM, but just hit a read access violation, so... That's cool. Have you got like a theme or like a game name that you've got going for your roguelike? Not yet. I mean, that's fair enough. Like with that kind of thing, you can just like I guess pick a style of game you want, build all the foundations, and then choose a theme afterwards. Binary space and partition trees. Yeah, that's like something that I'll probably have to look at doing at some point for like AI, using partition trees and like that kind of algorithmic stuff. Like I kind of have a rough idea of how I'm going to do a lot of the AI optimizations. And I think those are two techniques that I'll end up using as well. Alright, we've got this thing here, change voxel ellipsoid, and now let's apply a smoothing cube to that. So right, how do we determine the int min and int max? So we, I think for this one, just take the x center and then take away the diameter. And then kind of the same thing for everywhere else really, but obviously for each axis. And then obviously we need our maxes as well. Oh, I've just overwritten that by accident. So yeah, we need our... Why is it doing that? There we go. It's a lot of variables in here. Need to copy this as well to get our Z max, so that we know what range we're doing it in. So now we've got our ranges. I think that's it actually. I think that's all we need for our function call. Just double check that I've got everything right there. So taking away for the X, adding for the X, taking away for the Y, adding for the Y, away for the Z, adding to the Z. Right, I think that's cool. Sounds about right. To be honest, I have absolutely no idea what this is going to do. I don't even know if it'll do anything, to be quite honest. It might not work at all. Might just crash. So, moment of truth, I suppose. I'm not even sure if it'll compile properly. Like, all of this stuff that I've just been doing has been purely theory up to this point, and if it works first try, I'd be incredibly surprised, but more than likely it won't, so we'll see. Oh, I'm really hoping this works. Really hoping this works. Or at least something works and then I can test it. If the whole thing crashes, then I'm screwed. It's going to take ages to debug, so I've got to do, I think, 3 different functions. All doing quite abstract things, so we'll see how it goes. And Nalex, if you're still there, by the way, like if you follow along with my work and you actually make it somewhere with your project, like by all means, like keep me updated. I'm super interested in what other people are doing, so like it'd be quite cool actually if I had a lot of my followers coding as well. I think that would be quite fun. It's like we can help each other in different ways. I think, this is probably the longest compile so far that I've had on the stream. Oh, you've been thinking about streaming as well. I'd say it works, definitely. Like, even though I don't have many people viewing it actively at the moment, it's like, because you're online, and like for me this is probably going to be going on YouTube at some point, I kind of have an obligation to sit there for the 3 hours that I'm streaming and just like purely program. I can't really take a break and I can't let myself get lazy or stop. So I'd say it is really good. You just have to be strict about when you stream, like get a schedule and stick to it. Like it's kind of common streamer advice, just to set up a schedule like I've got at the bottom and stick to it religiously. Don't burn yourself out though, like don't try and program too much because you won't have fun. But it definitely makes you more productive. I've definitely found that it helps for me anyway. I wonder if I've broken it. I don't think I have. I think it's just got a lot to do, but there's a really long compile time. I guess I have kind of changed a lot though, to be fair. I think what I need is like some kind of game to play that's kind of quick while it's compiling. I'm not sure what though. Yeah, fitting it in with school is always a problem. Especially if you're doing school full time. Like, I'm thankfully now, like, I don't have uni or anything like that, so I just, like, literally have all the time in the world to do whatever, and this is one of the things I'm doing. Okay, right, so we've got an error. Okay, that's relatively simple. There we go. Didn't initialize it. Fair enough. Let's compile again. Hopefully it won't take forever this time. There we go. It's actually it's done something, and it's not crashed. Well, that doesn't appear to have done anything, so that worries me a little bit. That is a bit concerning. Right, now I've got to figure out where. I'll start up from the top and see if anything jumps out, just in case I've just done something silly. Right, so let's start at the point of call. So we are going from... So from here we're saying we want to smooth this cube region of taking the x-center minus the radius plus 1, so that we're covering just outside of that range. Again, x max. Yeah, we're adding that, x, y, x. Okay, so that seems fine. Nothing wrong with that call. If we go down to smooth cube, so we've passed in all these parameters. I know this for loop works because it's used elsewhere. we've got our array of corner changes. For each of those, we're making it equal to the corner value in each position. Let's jump down to here quick. So, giving it the X, Y, Z of the block that we're currently at, I believe. Should be anyway. Yeah, I think that's right. We're saying if there's something in these positions, then take away from the tally. And then we're saying if it's less than 0, return -1. We've set those. And we're determining the block type based on the corner changes. So let's jump down to there, see if we've made any silly mistakes. So for each, so we'll run through 4 times, and if any of these things are true, at any point, we set them to a number. I think that's fine as well. I don't think there's anything wrong with that as such. The only thing that I could think of that maybe doesn't work properly is this section here. So what I'll do is I'll change this slightly to be if the shape is more than 0, i.e. it isn't air, basically, then call this code. I think that's a bit more robust. I think that works better. Oh, I can't copy the whole thing though. Have to manually go through as you do, which is annoying. Okay, so if there's something occupying that space, decrement the tally. Yeah, I think that should be fine. And close that, we don't need that. Let's compile it again. And let's play. Oh, it didn't like whatever I just did. I feel like it's gonna crash. Oh no. Just just got rid of everything. That's weird. Oh, that's really strange. And I've somehow just crashed it. Right, so something obviously is wrong somewhere. It seems to be in the smooth cube function that it doesn't like. That's weird. Might be able to like maybe step through it and see if I can find anything wrong. So the most obvious place that I can think of where it would start to go wrong is here, so I'll put a breakpoint in. Now, I don't think I've actually done any debugging like this yet, so I don't know exactly how it works with the Unreal editor, but I'll give it a go as I normally would debugging any C++ code and see if it's the same. I don't think it is. I think I'm going to have to do it through the editor instead. But it did something, at least. It didn't crash this time. Although I suspect it will. Run it through here instead, see what it does. It seems to be opening something else. Okay, that's weird. I'll step through if I can. Don't know why it's not giving me all my normal. Where's my debug buttons? Oh, I can't use them apparently. Okay. Let's look into quick how to do C++ debugging in Unreal. So I would have thought it's like pretty much the same as using the editor, but so far not sure if it is. So apparently doing something like this should allow me to run through it. So if now I build it, okay, so that should be fine, I think. And then apparently I attach to process and find the Unreal Engine. Not sure if it's the editor I need to attach it to. I think yeah, I just attach it to that. And then I run... And now apparently I run it from within here. I'll be impressed if this works, not gonna lie. It seems to have done something. Just what exactly, I'm not sure. Oh, that's weird. Guess I'll try recompiling it and then try running it again. There we go, it actually did something. So that seems fine. Don't know why it's showing me just said that. Cool. Okay, so I immediately know what the problem is on this. Just so happens that we're testing X, Y, and Z as if they're out of bounds. So what I will do is just wrap all of this in a function that basically just says if it's in within the world boundaries, basically. This is going to be tedious to write. So if x, I don't know how to write this really. I guess I can do it outside. I can just check all of these parameters and then I can assign them different values. I'll go through for each one. This is going to be messy, so you have to bear with me. So if xmin is less than 0, then obviously I just want to set it to 0, and if it's not that, then I just assign it xmin. Bit of a odd solution, but I guess it's one that works. Where I'm just basically checking the bounds, but then I'll also need to do that for when I'm checking relative to itself as well. So if it's more than or equal to, I suppose, world width, return world width, else return x max. And then it's basically just a matter of repeating this process over and over again, but changing my variables to be the right ones, that I'm not just testing x repeatedly. Right, so that should fix one issue, but then obviously there's the issue of, well, of essentially the thing that I'm reading from in other areas being incorrect. So in this case, it's fine now. Like I've fixed this read error, which obviously won't be allowed to happen now. Like I think what it was doing before is reading outside of the bounds of the array. So it makes sense that that wouldn't work. But now I've got to also make sure that it's doing the same thing within here. So this is probably going to get very messy now, which I really don't like. But I don't think I have much choice. I know that it hasn't fixed the problem just yet. What I'm going to do, save that and just see if it's fixed the temporary like crash that was happening. I know I need to put more fail-safes in place, like stuff, but I just kind of want to see if I can get it to work at this point. Just so I know that it is actually doing what it's supposed to be doing before I refactor all of my safety stuff, basically. And it's taking a while, which is worrying me. And again, it's just not showing anything. Right. Let's try debugging it again. Might need to recompile every time I add in a breakpoint. Hopefully this works. Why is it not triggering it now? Certainly triggering me, that's for sure. I guess I needed to do that, maybe. No, that didn't even trigger it, so maybe I do need to recompile after having attached it to the process. So let's try it again. And again, it's not triggering my breakpoint, which is really frustrating. What? Why on earth is this not working then? I feel like it's not rebuilt it properly for whatever reason. Why won't it be hit? It should be hit. Oh, maybe it works now. I don't know. There we go. Right. You see, that shouldn't be -2, unless it's just not been set yet. Maybe it's because I didn't wrap it in brackets. Actually, it might just be evaluating the first half of this return and going, oh yeah, this is fine, and just returning that part. Can't see why it would, but it might be the case. Let's replay that, or rather recompile. Right, let's try and get it working again. Ah, this is frustrating. Right, okay. Just in case I've messed something else up, I don't think I have, but on the off chance that I have, if I go back up here, comment that out, and in fact I don't even know why I'm doing that every voxel. I don't need to do that every voxel. Put it down here somewhere. Try rerunning it just to make sure I've not broken my ellipsoid generation, which I doubt, but it is possible. Okay, so this is still generating, that's fine. Right, let's just see if putting it where I had here fixes anything, because I suspect that for whatever reason putting it there has like maybe overwritten some things or whatever. That's useful. Right, let's recompile it now that we've got that back in, but not running every time we change anything, which isn't good. We want it running just the once. This is frustrating, like having to wait all the time for the compiles. I wish it was as fast as doing it in the actual editor. Done something. It's not actually what I wanted it to do, but it has done something at least. It's odd that it's chosen to do it on just the bottom ones though. Maybe there's a reason. But that's actually kind of the opposite effect of what I wanted it to do, which is really odd. I've got to retest my logic. I'm sure I'm doing something wrong. Weird as well that it's only affected, I think, one side. That is really bizarre. That should not be happening at all. Right, let's let's take another look at what we're doing. So, purpose of this whole code is to take all of the top faces and smooth them out if there's something lower than it, essentially. So this is what determines whether or not a change should be made in the first place. So for each corner we're going through and saying, okay, let's check the adjacent voxels. If there's anything present, we'll decrement this value here, which I think is fine. So for the first corner that we've got, which is the bottom left one, we're checking same X position, just Y minus 1, Z minus 1, so basically in its own bottom left corner. Oh, sorry, no, on its left hand side. Is there something there? So is the shape in that position more than 0? So is it not air, basically, I think. Let me just double check that, actually. Yeah. I think that's fine. Unless maybe I'm not setting that in the change voxel function when I do update the voxels. I'm setting the shape. Ah, but I'm not updating it here. Okay. Oh no, it's up here I'm doing it, sorry. Right, so shape, material, rotation, so they are getting set. So we're taking voxel shape in. So it should know that something exists in that place. Now the next bit that might be causing us issues is this whole thing. So it should in theory go through and it's like it should basically check these configurations of like patterns and say, does this exist? Yes. If not, leave it as default. And for whatever reason, only the ramp is showing up, and only the ramp is showing up on the bottom side. That's what's confusing me the most. So either something's wrong with the patterns themselves, or something is wrong with my shifting. Which I could kind of understand, like maybe I'm doing something just a bit dodgy here. Okay, so if there's a block underneath it, leave it as shape type 1, that's fine. So the ramp one is this setup. So if we're finding this pattern, we're setting it to shape type 4. I find it strange that that's the only one that's getting used. Really odd. Run it again, there might be some reason to it. See if I can spot why. Kind of wish I had lighting on that side actually. Let me put in. Oh, I've already got a skylight. Let's see if I can edit its properties. Let's make it so it doesn't cast shadows, and then I can see the whole thing. Try playing it again. no, it's not shadows I want, is it? I'll turn up, I guess, indirect. Not sure if it'd be indirect lighting actually. What if I just add in another one, but from a different direction? I think I can change that. Not actually sure what direction this light will be in, but I need it rotated up instead. Not quite the effect I was after, but it's nearly there. If that's the right direction. Yeah, well, at least it gives me some visibility. So it is. It seems to be exclusively doing ramps from what I can tell, which is really strange. If anyone in chat can like spot something maybe that I'm doing wrong. Oh no, it's got other block types as well. Oh, that's weird. It's just doing them in completely the wrong place. Okay, so it's doing them. Right, trying to think of like why this might be happening. It's doing them on the bottom side. So for whatever reason, it seems to be thinking that. Oh, I have no idea. I'm lost at this point. It's not doing it over here. Unless it is and I just can't see it. No. What about under here? Maybe it's doing it under here as well. Obviously some kind of like logic issue that I just haven't thought through properly, or like this one actually does kind of make sense. Like I kind of get it. There is actually something down there, so it makes sense that it would ramp. I don't know why it's choosing the block type that it is, and why it's not doing it for up here, because surely if it's working down there and it's working correctly down here, then it should do the same for the top. So let's go through again. So we're saying for each corner, if there's something lower than it, let me just double check my shape patterns as well, just in case I've done something wrong. So I think I checked this one was fine. So for the next corner we want negative y, negative z, yeah, that's fine. We want plus x1, negative y, yeah, that's fine. Again, we want plus x1 and y, yeah, that's okay. guess one important rule that I need to put in place is if there isn't something covering its top, that's important, that I've missed. And that'll actually fix the problem that I'm currently having, but not the fact that it isn't working anywhere else. So what this is saying is if the block above the one that I'm currently looking at is greater than 0 in terms of its material, then we know that it's air. Sorry, we know that it isn't air. And therefore we should run this whole block of code. And maybe I should use material instead of shape as well for these other things. I think that might be causing an issue. So it doesn't ultimately matter what shape there is. What matters is that there's actually a material occupying it. Okay, so that's obviously not working how I expect it to, because this these blocks here shouldn't even be running this code right now. Like, it shouldn't even be doing any smoothing. If there's something above it, which there is, it shouldn't run the code that it is. It's really confusing. We've also got some blocks moving the other way as well. Oh, God knows, honestly. Is it doing anything on top this time? No. I think it's behaving slightly differently than how it was before. So let's look back again. So, if the thing above it sorry, that should be not greater than 0. So if or should it? Yeah, sorry. We want the thing above it to be if it equals 0. Had a bit of a moment there, I don't know why. Must be tired of looking at this code base. Right, so if it's if the thing above it is 0, i.e. the thing above it is air, then run the deformation code, the smoothing code. That'll have fixed all the issues I'm just having. So this is actually working now how I expect it to. I think. However, this is running in the opposite direction, and it isn't working for half of them, which is weird. I mean, I can kind of take a few guesses as to why it isn't working properly, but let's get rid of these light sources, just because it's hard to see what's going on with them in. See if that makes it any easier. And now I can't see anything. Put it on unlit mode. Does that help? No. Let's try. I'm not sure what mode would be best actually. Oh. There we go. Maybe it was that mode, I just needed to do it in play. So some of these are working, and they seem to be working in the correct place as well. But it's only this type. It's only the corner ramp by the looks of it. This side isn't working. And like, so for this one here, I would expect like some kind of ramp or something like that, at the very least. So thinking through how it works, I guess actually what it'll do is it'll check this one and see this is confusing me, honestly. Normally I think I'd be able to work out this kind of problem, but for whatever reason my brain just isn't working right now. I find it interesting that only one of them is doing the thing that it's supposed to, and it's only on one side. Well, and it's in the wrong direction. So I think I might have a rough idea of what's going on here. So basically it's checking all its corners or all the blocks around it, and it's saying, okay, all of these have things occupying those spaces. Therefore I'm going to be a neutral block. Whereas what we actually want it to do is to say this block is next to it and doesn't have something on top of it. So instead what I should be doing is, I guess in this part of the code here, I should be checking if the material is greater than 1 and it doesn't have something on top of it. So using the same code that I just used up here, basically to say and it's air. Obviously you have to copy the block spacing and everything. Oh, this is going to be a big manual job, I think. So yeah, that's -1. Sorry, it just took me a while to wrap my head around that. So copying this section, we'll just put that into there. And then we'll go through each one individually and set the relevant spaces so that we're not putting it in the wrong place. So that we're not checking the wrong block position, basically. Well, actually, it doesn't need to be +1, it just needs to be Z. I'll set all of these to Z. Again, another big manual job. I'm sorry, this isn't very interesting to look at. And then we have to go through each space and basically make sure that the same two parameters for our array are the same. So this is going to take a while, but basically just copying and pasting repeatedly. So you'll have to bear with me. Please let me know in chat, like, if anyone's working on something more interesting than this at the moment. There's probably a faster way to do this, to be honest, but I have no idea. Hopefully I've done all of this correctly and I've not messed something else up. No doubt I've done something wrong, but we'll see. Recompile that. Let's play again, change the lighting mode. I mean, it's kind of doing kind of doing the wrong thing, but what on earth is it doing? I mean, that side's kind of close. Like this is kind of doing roughly the right thing, I guess. It all seems to be oriented the wrong way. Like this one as well here, this shouldn't be doing anything at all because it's all of the ones that are below it, around it. Like they should, like they have things on top of them, I guess, other than this one. But then if anything, it'd just slope down in that corner. Oh right, unless that model's rotated the wrong way. That'd make sense. Still kind of weird though. I reckon I've got some of my values wrong somewhere in my checking code. Because I would have expected both of these to do something, but they haven't. Only one of them has. So evidently, some of my position code is slightly off, which means I have the fun job of checking every single one thoroughly. Right, starting from the top. So, bottom left position. We want to check the left down. Yeah, that's fine. Then we want to check the diagonal and down. Yeah, that's fine. Then we want to change the bottom and down. Well, I mean, these two lines should be reversed, but it doesn't matter. It works anyway. Then for the bottom right, we want to check the thing on the same x-axis, but below it. Yeah, that's fine. Then we want to check the thing to the right of it diagonally. So going down diagonally, yeah, that's fine. Then we want to change in going to the right of it, yeah, that's okay. And then we're changing, so now we're doing the top right corner. So we're checking positive x, same line. See, this might be the thing that's wrong. We want... Oh no, that's correct. Yeah, positive x, then positive x, positive y, then same x, same y, sorry, positive y, that's fine. Now we're checking the top left. So we're checking above it, yeah, then to the top left of it, that's fine. Yeah, that's okay. And then we're checking just to the left. So all of that seems good, I think. I don't know, I'm thinking maybe I've messed up somewhere else. Maybe it isn't this. Unless I've done my copying wrong, which I don't think I did, but is possible. Just quickly double check that, it won't take as long though. X minus y, yeah. Plus minus, plus minus. Plus minus, plus. Yeah. Yeah, so that's all fine as far as I can tell. I don't think I've done anything obviously wrong. If someone spotted something, then please tell me. So the only other thing that I can think of is maybe I'm doing my maybe I'm doing this function wrong potentially, like maybe the rotations are off or something. So we consider Hmm. Maybe it's the shifting. Like, if I get rid of this function, I can probably do it manually and hopefully it'll be a bit more accurate as well. Like, anything could be the issue at this point, so it's worth just testing a few things, messing around a little bit. Yeah, that seems alright for now. That should shift it round. And we're doing that shift. So 0, 1, 2, 3, well, yeah, we're doing this whole process 4 times, which I think is correct. Like once for each possible rotation. Potentially my rotations might be wrong. That's a valid possibility, but even then I wouldn't expect the results that I'm getting. Like, I'd expect the blocks to still change shape, just be the wrong orientation. So I can fix orientation, that's like relatively simple, it's just changing the offset. Yeah, it's weird, we're only getting it on one side. Maybe my entire approach is wrong. Maybe it is. Like, as much as I'd hate to restart this work, like, I could be just approaching this from completely the wrong way. But, you know, at least I've learned a few valuable lessons, or maybe I've got some workable code in some places. I think the biggest part of the code that I'll need to change is if I show you, I mean, this part here, not only does it seem like it's a mess, but it also probably isn't the best solution anyway for determining what corners should and shouldn't be down, at least. I find it weird that it's doing it only on one side though. Like, that's to me the most confusing thing. Because, like, at the very least, like, all 4 of these should have changed, but they haven't. Which is really bizarre. I can try rebuilding, maybe it's just not picked up a change that I've done at some point, so I'll rebuild solution. Sometimes that fixes certain issues, although I wouldn't expect it to change this kind of stuff. I think unless I spot something obvious though in the next, I don't know, next 30 minutes, I'll kind of end the stream. If I spot something, I'll obviously go through it and fix it with you guys, but if not, I'll end it there, kind of go away, come back maybe Thursday with a fresh set of eyes and see if anything jumps out. Okay. Oh great, so now it's showing me other errors. That's nice. Try doing a rebuild using a different thing. Probably take its time, to be honest. Nearly done by the looks of it. Taking an awfully long time on that one. There we go. Now it's actually worked, so let's recompile it in here. Just in case there's some like undetected changes, maybe that helps in some way. But we'll see. No doubt it'll take forever now that I've rebuilt the entire solution. I mean, I think, to be honest, that looks slightly different from what it was before, but I'm not entirely certain. And again, it's still only doing it on one side. Like, if this was a... If this was, like, being built, if the sphere was being built as it was doing the smoothing, I'd understand these kinds of results, because it'd tell me that it's like smoothing as it goes through in a way. But because it's doing it after the fact, I can't for the life of me see why it'd be smoothing in such a bizarre way, given that I've double checked everything. If I go to my... Yeah, so smooth cube is being called after the whole ellipsoid is actually being built. So the whole behaviour to me is really, really odd. I'm kind of determined to figure out what's going on though. If we look at the types of blocks that are versus the types of blocks that aren't being actually changed, we might be able to figure it out. So is there even a clear pattern? I mean, so this one's like, okay, there's only one block 3 on this side. In fact, let me double check something. Yeah, that's all correct as well, I think. Just so strange. I just don't understand it in the slightest. Like what's actually happening here? These blocks should be indexed correctly, so I don't think that's the problem. Sorry that this isn't very interesting to watch, by the way. Like I'm getting quite like frustrated more than anything at the moment, so I've absolutely no idea why it's only doing that side. I'm beginning to think though that I must be doing something fundamentally wrong, so I'll look at this from a different perspective and see if I can come up with an alternative solution, and hopefully that fixes the problem. I think like my code for determining what side should be down versus what side shouldn't be is probably fundamentally wrong. But I think the other stuff is fine. I think like the bit pattern checking thing, that's all good. Because it seems to be doing something at the very least. And I think, yeah, I think that code, that's all good. So if we change the way we determine what shape to use, surely we can come up with some kind of solution. So instead of thinking about it in terms of corners, maybe we can just think about it in terms of adjacent blocks. So in this case, we know that we have 2 adjacent blocks. So we would use one with I guess we'd use the we'd use that one. So we check each edge, and then the corner that we decide to, I guess, turn up or turn down is dependent on the sum of the adjacent sides, with the lower I don't know, maybe it'd work, maybe it wouldn't. There's probably issues with that what I'm not saying right now. Yeah, like one issue I can think of right now is like, let's say we do have a situation where it's just a corner, then it would just end up using this one, and that's not the right shape. Not quite, anyway. Like, I would expect this one to be used. So, what like relationship can we tie together from that? Like, is there a mathematical relationship that we can kind of use based on the amount of edges that it's next to, or the amount of corners that it's near, or like the height of the adjacent columns, or something like that? So, like, maybe what we could do is take this center point and, like, check. Sorry, hang on. There's a bot in chat again. I don't know why there's so many bots in chat all the time. It's really annoying. You'd think for a small channel they wouldn't bother. Yeah, a bot that says it's so random and so funny. I actually don't know how to mod stuff. My friends who have mod access will know. There we go, I banned a person. Right, now I can actually get back to work. Yeah. So let's take... So let's say we do use this block because we've got a block here and a block here next to it. I guess the thing that would determine us using this block in particular would be we take this corner and we'd say, okay, what's the stuff around this corner? And we'd say, that's normal, that's normal, that's normal, therefore it must be raised. And with this one we'd say there is no block, there is no block, there is no block. Like for this corner anyway. And for this one it would be there is no block, there is no block, there is a block. Therefore the average is that there is no block and we lower them. Like that could work, I guess. Like that would potentially be a good way of doing it. Like doing it on averages. But then there might be situations where it doesn't work, so it's hard to predict. Like let's say we have block here, block here, block here. And how would that work? Like this corner would then say no block, no block, no block, block, lowered. And then this one would say no block, no block, no block, lowered. So I guess that would kind of work. So yeah, I guess we do it based on average number of blocks adjacent to it to determine the corner's height, rather than this like convoluted checking system that we've got. I mean, we'd still have to use something almost equally as convoluted, but it wouldn't be quite as bad. So oh, but then what if there's what if there's blocks on top? Then that wouldn't, like, the same rule wouldn't apply either. Yeah, this whole issue is a bit of a nightmare. I think what I'm going to have to do is I'm going to have to end the stream very shortly. I think I'm going to have to go back to some pen and paper, maybe brainstorm some ideas, come up with something a bit different, come up with a different approach maybe, test a few different use cases out, and see if I can come up with something that is yeah, I guess something that's different, because obviously currently the solution isn't working. I don't know if I've just made a mistake in my code or if it's fundamentally broken, so I'll go back to the drawing board. If anyone has any questions or anything before I go, then feel free to ask. If you want to follow as well, that would be like a massive help, like before I close the stream, just so that you can come back and watch me again. Like, hopefully I'll fix this problem in the next one. So I guess it'd be quite fun to watch. But for now, I guess that's it. Thanks for watching up to this point, if you have done. Thanks for watching if you're on the YouTube channel as well, by the way. It means a lot. And I guess I will see everybody next time. So thanks, guys.